Hi everyone, today we are going to talk about the mapping module, so ArcPy.mapping module within the Esri environment, and then we are going to learn how to create Toolbox. The ArcPy mapping module gives you access to many properties, not only of your maps, also of your layouts. We can see how we can access properties of different layers within a map, how we can automatically change the title of a layout, for instance. And then we will learn how to create toolboxes in which you can incorporate a script, essentially, and how you go about sharing those tools to the wide community. I will now briefly explain the mapping module and what you can do with it. And later on, I will, of course, show a bunch of examples within the Arc Pro environment. So the ArcPy mapping module, right? It's a module that gives you access to many methods and properties of the elements that make up a project in the Arc Pro environment. Example of elements could be the maps, of course, could be the layout, could be the layers, and of course many other things. So for instance, when you think about a layout, you have, of course, the map, you may have the title, you may have the legend, you may have the scale bar, north arrow, and so on. And those are elements of a layout. And we'll see that there is actually a certain level of hierarchy. And so, for instance, how to access, those different elements. So the very first thing we do, of course, is import ArcPy. And then we want to point to the Arc Pro project by using here arcpy.mp. MP again is the mapping module. You only need to call it one time. .arcgis project current. Now that current here could be, of course, changed and give the full path of where your project is located. From there, you can point to a map. We see that now we are using the project.listMap. So .listMap is here a method that allows you to list all of the maps that are part of your project. Likewise, if we go one level of hierarchy down, we can also point to a layer by using m.listLayer. So listLayer is a method of a map. And even further, we can access the properties of the layers, such as, for instance, the transparency, or maybe the data source, maybe the name. In case it's a choropleth map, or if it is a raster, we can change the number of classes. We can change the type of classification method that is being used. And what you would do then, you would point to the layer, the very first one, second one, third one, whatever. And then afterwards, you would have .name or .transparency or .data source, which in this case is a property. And then finally, to access a layout, this is going to be the same where we have the project, and then we're going to have the function list layout. So, of course, there are many, many more of these options here, and I'm going to demonstrate a few within the Arc Pro environment now.
Okay, I'm going to demonstrate some of these lines of codes that I have explained just briefly earlier. I have to my right here a Google Doc that has all of these different scripts here, or lines of codes, and to my left I have a ArcGIS Pro project with my Python window open here. So as I mentioned to you, the project is made out of maps and as well as layout, if you have a layout, and each of these maps is then made out of different layers. So in the case here of this map called pizza map, we have 1, 2, 3, 4, 5 different layers, right? So going from 0 all the way to 4 when you try to access them. Okay, so let's have a quick look here at how we get started. So to identify the path of a project, for instance, so we're going to use import ArcPy, and we are going to then point to the current project right here, as you can see. So I'm going to put this a little bit bigger, also make this a little bit smaller. All right. And of course, if you were working outside Arc Pro, or you could also work inside RPro, but you could change the current here with actually the location. So that is fine. And here will tell me where that particular project is located. You can save it at any time by using p.save. Now, if you're interested to find out the different maps, so the way to do it would be by saying m is equal to p, and when you press the dot after p, it will show you a bunch of properties here with the blue circle and a bunch of methods here with the m in there. And so if I want to list all the maps, I could do that, right? So that would be fine. So I can say m, and m, you can see here, has a total of 0, 1, 2, 3. So there are 4 different maps. Now you can maybe wonder why there are 4. I only see 3 because within the layout there is also a map. And then you could say, for instance, for I in M, right? So M is the list. Then you can say print, let's say I dot name. I think that's good. Oops, I dot name here. All right, perfect. And let's see what happened. And it would essentially tell you the different maps. So pizza map is the first one, the second precipitation IO, the third one at pharmacies. And then there is one that's just called map, and that's the map within the layout, as you can see. So you could also, for instance, point to a particular map. Now let's say I put this M1, right, for map 1, and I'm going to say is p.list maps. Okay, so that is good. And I want to work with the very first one, so which is pizza map, right? So we're going to put that in, and we can check whether or not, you know, this is correct, right? Pizza map, okay, we're on the right one. You can say what are the map units, for instance. So m1 dot map units, right? Map type, metadata, bunch of different things. Here you go. And then the next step, of course, is to access the different layers, right? So we can put here, for instance, layers. I'm gonna just write layers is equal to m1, okay, dot list layers. Here we go. There we are. And so that's the list of all the layers. We can ask what layers, and again, it's arcpy.mp.layer object. We can also, for instance, get the name of all of these layers, right? So print again here I dot name here, okay. And now we have indeed the name of each of these various layers. You can also, for instance, say for I in layers, right? We can also, for instance, say print I dot data source, right? So we know where they're coming from, and you can find out then where the data is located, which could be actually useful as you're trying to locate some data set. We can access other properties, of course, such as the transparency. So here I'm just going to change I data source to transparency, for instance, and we will see that all transparencies are pretty low, and one is a little bit higher than. And if we wanted to change that, we could, of course, do that. So, for instance, the issue is that you need to access a particular layer. So, in the case, let's say I want to change the background, the county, which is currently dark purple, I think it's too dark, so we could change that. We just need to know what layer we're working with, so that would be 0, 1, 2, 3. Sorry, 0, 1, 2, 3. Yeah, that's it. So you would simply say then for that particular layer, let's call this layer A, right? So you would say is equal to I and I would call this 1, 3, as I mentioned, right? And okay, so that's not the right thing. Sorry, layers 3, my bad. Okay, and I can then do layer A dot transparency, right? We know it's 10, and I could change this and say I want this to be 80, for instance. Okay. And we see what happened. The background has changed now, and it's much more transparent. Okay, so that's quite useful. So that is great. I'm going to move now to a different map, the second map here, precipitation of Idaho. And what I'm gonna try to do here is to see whether or not I can change the transparency of the raster. So the way to do this, of course, we need to go back up and change what map we are working with. So we're going to work with the second map here. So I'm gonna start working here by changing this. Call that 1, and I'll call that 2 map, second map. Okay, it's a bit confusing with the numbering here, but it's okay. And then we know that precipitation, is the layer the third layer, so number 2. So we'll go here and we're gonna do layers here. I'm gonna put layers 2 because the second map is equal to m2 dot list of all the layers. That's great, perfect. And now we know that precip is equal to layers, okay, and we know this is going to be layers, the second one, right? And we're gonna double layers 2 here, second one, and we're gonna double check to make sure that this is correct. Precip dot name, and it's at precip, so that's good. We are working with that particular layer. And now what if I wanted to change the number of breaks, right? How to do that? So that's a problem of classification. So we would then access what is called the symbology of that particular layer. So what you would say the symbology, right, is equal to precip, and then you would do symbology here, symbology right here. You could print what that symbology is. Won't tell you a whole lot, just that it's a symbology object. And you could also, for instance, find out how many breaks there are. You also have class breaks. You can change the classification method, other things we can change. So symbology colorizer break count, and it would tell us that it's 5. Now, if I wanted to change this to, let's say, 9, I could do that. The only thing is that later on, I need to make sure that I do change the symbology of that particular layer, which was, if you remember, precip dot symbology is equal to sim. See? And we see that the number of classes has not changed to a total of 9. As I mentioned, there are other things we can get, of course, in that symbology. So we can, for instance, find out what classification method is used. It's natural breaks. We could change that to another one if we wanted, and so on and so forth. We can move the layers using the move layer function. We're not going to do that. And then now I want to spend a little bit of time talking about layouts here. So here we have a layout. There are ways we can export the layout. So the first thing, of course, is to get to the layout. So let's call this L is equal to P with the map. And instead of listing the maps, I'm going to list the layouts. Okay. Now there is only one layout, so it's pretty straightforward. So maybe you could have cases where you have 2 layouts instead. So here you go, and you can say, for instance, l.export, and there are plenty of ways you can export your map to PDF, EPS, a bunch of different format to BMP, and then here you would simply say where you want this map to be saved. So here ctemp and say map .bmp. Now there are other things you could add as arguments, essentially the size of the map, the resolution, but we're not going to worry about this right now. We'll just go with all the default. And you can see it took a little time. And so now I can navigate quickly to my ctemp and see whether or not it is available there. And we see the map is available. And we're going to see this in 1 second. Here we go. Okay. Okay, so that's on the first part. Now, I'd just like to spend a little bit of time on how we could automate the layout export. So for instance, let's suppose that we want to change the transparency of the precipitation in Idaho. The precipitation in Idaho is the map actually inside the layout. You know that map number 4. And here I do need to make sure. So I have a little piece of code here, and I do need to make sure that I'm working with the correct layer. So let's go here. This is indeed the 0-1 map, so that's good. So we have the different layers, and precipitation 0, 1, 2. So this is A2, that is correct. Transparency I, and okay, and then I basically have a script, a for loop here that is going to change the transparency and going to write it out to the temp directory, example transparency, and where I export to a JPEG, and the name changes every time. Okay, so we're going to see, so it's currently creating those right now as we speak, so we can go to the temporary and we see how these are being changed. So we're just gonna wait a second, make sure that they're all there. There we go, so it's finished. Okay, it didn't do the 100, but that's okay. And that would be transparency of 0, that would be transparency of, sorry, transparency 0, transparency of 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, it's really nice. The problem, and so that's really where automation works nice. The only problem I have here is that I have no idea that it is 10, 20, except by just looking at the title, by looking at the name of that particular map. So how to go about adding maybe a title and then automating that function so that it at least appear on the map, that would be good, and that will be what I will show next. All right, so I'm back here again, and I wanted to show you how you can automate, of course, the export of a layout, but where you change the title of this layout every time you change, let's say, a property of a layer, let's say transparency, the number of classes, and things of that nature. And the way, so this is very much the same ArcPro project as I just shown, with the exception now that you have this layout, but in this layout I have added a title to it, and the way to do it is simply going here in the in new layout and basically adding here straight text, and you can add whatever you want. It doesn't really matter, so I could, you know, call this title, for instance. Right, so I could call this title, and that would be fine, right? So what I want to do here to demonstrate how this works is the same example where I'm going to take the precipitation of Idaho. I'm going to change here the transparency level. As you can see now, its transparency is close to 100 probably. And I've written a code here that allows us to do just that. You will notice something interesting here is that in order to access this particular element of the layout, there are a couple of things that you need to do. So once you have point to the layout, you are going to essentially list all the elements. You can list all the elements, and so there are different kind of elements in a layout. You have things such as the map itself. You have a title. You have a north arrow. You have a scale bar, and so on and so forth. And what we're interested in, of course, is to look at this text element, and there is only one. So I could have multiple text, and it would be text element 1, 2, 3, 4, but here we keep it easy, and this is why you have text element 0, and we can be, we can check here. So what's in what I'm highlighting here is not necessary, but if you want to make sure that this is what you're working with, you can get the property text of that element. And there again here, this piece is not necessary. It's just to make sure that I'm working with the right layer. And what is different now is in that for loop that I had before, I'm adding something which essentially is the fact that I'm going to change the title every time based on the transparency level that I use by changing here the property of that element with the name. Okay, so let's run this code and let's see what happened. I think this should work. All right, and you see that this does not change, interestingly enough, but this changes. Okay, in fact, this is changing simply because I do not refresh the layout, but it does change, as you will see in the image. So these are saved to the C temp. So I'm gonna check this out quick, and we can see here everything that has been added. Okay, and you can see transparency is equal to 0, transparency is equal to 10, 20, and so on and so forth, and we increase, right? So what is the nice part is that we have changed essentially the title. There are other things you can do. You can change, as I mentioned, the legend. You could have more classes, and the legend would automatically change, which is really nice. Okay, so that is on how to automate layout export by changing the title accordingly.
In scientific research, we want to try to share our code for purpose of transparency, but also so that other scientists can replicate our research. And one way to do that is, for instance, by attaching your script or your code to maybe a tool that can be then shared and disseminated among the academic community. So far we have learned how to write scripts using the ArcPy package and so on and so forth, and we also have seen how we can automate some functions. It's really nice if you could package this into a tool, and that's the purpose of this lecture as well. So we know that tools in ArcGIS Pro can be accessed from the Toolbox, and then those Toolbox are made out of tools, and those tools typically are either written in a specific coding language, like C#, for instance, or some could be also written in Python. So really the process on how this works, right? You have a code that is written in Python, and that code can be written in an external editor, like a PyCharm, PyScripter, for instance, or could be written in the Google Colab or other things in a Jupyter Notebooks, for instance. And it has the extension py for Python. The idea is that you want to attach this script to a tool or incorporate or embed it into a tool. Now, typically, when you write a script, as we have seen, we generally have inputs, we may have some parameters, and we may have an output. It's similar to a function with different arguments. Okay. So for instance, if I want to automate a buffer operation, for instance, I will have the input, which would be a feature class or maybe a shapefile. I would have a parameter that would be essentially the distance to which I want to buffer, and typically I would also have an output feature class or an output shapefile. Okay, so those would be that would be a very simple example. Now, if you wanted to automate the buffer operation and do multiple buffers, for instance, then you may have two parameters: a starting buffer and an ending buffer, and also maybe as a fourth or fifth parameter, maybe you would have the intermediate interval. So generally, those parameters then coincide essentially to boxes in which you are going to input those parameters. The way this is done, so instead of hard coding into Python saying, okay, this is the shapefile I'm working with, this is the parameter that I want to use, 500 meters. No, you're going to actually ask the user to enter those, right? You can use this input function. And then you are going to basically assign these values that the user are going to enter to a variable, and that variable is going to essentially coincide with that box, okay? Now, one other thing that is important is not just attaching the script and say, okay, that's fine. No, afterwards, you also want to tell ArcPro what kind of format should the user enter, right? Should it be a shapefile? Should it be a feature class? Should it be a number? So, for instance, in the case of a buffer operation, right? The input should either be a feature class or a shapefile, right? While the second, which is a parameter at which we want to buffer, that should be a number, right? Should be a number and should not be text, or if it's entered as text, then it should be converted to a number. And then lastly, in the case of the output, that also should be a feature class. Here we're receiving, so that's an input. Yes, we're receiving also the information where that output should be, but then this is a result. So this is something that is produced by the scripts. So I'm going to show a couple of examples about this buffer. One will be the example I just showed you, how to automate a buffer function through a tool for just one value. And then we're going to see how we can do it for starting value, ending value, and deciding on the interval.
Okay, in this example, I'm going to show you how you can create a tool in a toolbox. So typically tools are accessed under analysis tools here. You can access all the tools, buffer, interpolation, geocoding, and so on. But you can also access them, or you can create, your own tool through the catalog pane. You will directly find something called Toolbox. This will point to your project, TBX, and this is the same name as my project. Okay. So what you want to do next is either you can create a new tool set or you can just add a new script. Doesn't really matter. Okay. This will take me into a new window here where I can write my script, script name. So what I'm trying to do is a buffer operation. I'll call it buffer script and I'll call it simple. The next example will be a little bit more complicated. It asks me where is my script, and so this is important. Your script is going to be written in a Python editor such as IDLE, which comes with all Esri product, but also you could use PyCharm, PyScripter. There are plenty of different editors there. You can also use Google Colab and save to a Python script, Python file. Yeah. Just before I attach this, just want to show you briefly. This script does conduct a buffer analysis. It uses 3 parameters. We know that. Input shapefile, which is a shapefile that contains the points in our case. The output. This is not provided, as you will see, by the user. This is done automatically. And the distance field, which is the distance at which we want to buffer. There are 2 parameters in this script that are needed. The third one is also needed, but it is implicitly added here. The shapefile where the data can be found, and so we use something called argpy.get parameter as text 0, get parameter as text 1. Okay, so it's basically asking the user for some input here. The rest of the code is pretty straightforward, as you can see. So what you want to do here is to link that script to your new tool. So I'm going to navigate to ctemp because it's located ctemp. I have my script here, buffer py, and then the next tab is going to take you to the parameters. And there are 2 parameters here we're going to ask the user to enter. The first was his input shapefile. I'm going to use the same label. Okay, same here. Now this input shapefile is not a string, so this is going to be a shapefile, and you want to change the parameter here to shapefile. That's good. And the second one is distance field. And distance field is not a string, it is actually double, right? So this is going to be a number. You could put integer, but then if someone enters something with a comma, then it's not going to work. So I'm just going to go double here. Now, you see, as I'm going through here, you see all the different kinds of parameters we can have, right? You saw things like, geostatistical layer, feature layer, extend. There are plenty of different inputs that we can enter. As part of a function, in fact, it's the same. Okay, we are good with that. And then both are required. Now, the output is not provided by the user, but technically, we could add an output shapefile. But again, as I mentioned here, this is automatically provided. So if you don't have a ctemp, for instance, that's not going to work. So the script now is ready to go. So I'm going to call it. And as you can see, it's just asking for 2 things. I can't drag this because this is a layer. This is not a shapefile. So I'm going to navigate to my directory at the bus stops, and I'm going to ask for a specific distance. Let's say about 1000. We can check what the units are. Right here, we're talking in meters, so this would be 1000 meters. And we're going to run this. We see it's green, so something has been done. And if we are happy with that, we can close it. And we can add some data right here. So I'm going to navigate to the CTEM. And I'm going to add the data that was just created. Let's add it here. It's called buffer. So let's go and check this out. Buffer, CTEM buffer distance string. I want to refresh this. Buffer 1000 created at 8 p.m. That's right. And we can see all the buffer have been created. So again, I wouldn't say that this particular tool is very useful, but you can see the mechanism how you can attach your script into a tool. And the next example will be a little bit more advanced. In this second example, we are going to show how we can attach a script to a tool, but that script is a little bit more complex, a little bit more advanced. It takes actually multiple inputs from the user. So what we want to do essentially is to create a tool that will generate a bunch of buffers from a minimum distance to a maximum distance with a certain interval. So we're going to follow the same process as what we did before. We're going back to the catalog pane. We already have a script. We can add a new script here, and I'm going to call this script now buffer script, but buffer multiple scripts, okay? Or I guess I could call it multiple buffer scripts, okay? Because it's going to create more than one buffer, of course. Same label, keep things simple. And the script file here is ctemp buffer2.py, and I'm going to navigate to that one in the ctemp, and I see buffer, I'll just refresh, buffer2.py. So sometimes if you don't see a file when you look for it, just refresh. The parameters, there are more than one parameter. This time we do have the input shapefile, that first parameter 0. I'll make sure that it's here, same thing. And as we saw before, this is a shapefile right here that is required. The second is the distance field minimum, okay? So that is one of the parameters that is not a string, but is a double as well, as we saw earlier. Okay, that's required. The distance field maximum, right? So up to what distance do we want to buffer? That's good, and it's also a double. Here we go. And then the very last one is distance field interval. We have here, and that is also double. Here we go. Perfect. Now this should work. And then if you look at the script a little bit more carefully, it's going to essentially say what is the I'm going to buffer. I have a while loop here, could also be a for loop. I'm simply going to buffer until I reach this maximum distance. So let's call this script multiple buffer. As you can see, it does have here a few components. So the first one is the bus stops. We know that one. What is distance minimum? Let's say 100. Let's say the distance maximum, let's say 2500. And let's say the distance interval is about 100 here. So every time it is going to create a new buffer, you can see here how the name output is going to change based on distance field string, okay? And that is going to give a specific name. So let's run it. So it might take a little bit of time, okay? You can view the detail if you want of the script. But we can also navigate to the ctemp right here. I'm gonna do that. And go into ctemp. That way you can see the progression, right? We started buffer 100, 200, 300, 400, 500, and so on and so forth. And we say we were going to go up to 2,500. Okay, so interestingly enough, we started at the maximum value, which was 2,500, and then we went down, we decreased by the distance interval. And now we can go and add this data to or map. So refresh here one more time, okay, and those are called buffer. Okay, so we're going to scroll down. You can see those have been done at 8:17 p.m. So that's right now, and we can add all of them right here. Takes a little bit of time, but you can see how this has been quite useful, where you have all of these buffers that have been added, okay, and so on and so forth. So I can turn all of them off, or just one at a time. Let's scroll down a little bit more. So we started buffer 100, very small, 200, 300, 400, 500, and so on and so forth, and you get the gist of it. The nice part of this, it's very, very fast, right? So if you had to do this by hand, it's very complicated. And I can go again, right? I can go back again to my my script. I can go back to my catalog pane. I can rerun the script again, just adding the bus stops, right? And I can say distance field minimum, let's say it's 100. Okay, distance field maximum is, let's say, 200. And let's say I want a distance field number 1. Okay, so that is going to create 100 different buffers, and I can run it, right? And of course, this is going to take a while, and we can see the progression of those here in the C tab. But you can see how quickly it goes. So we started at 200, 199.98, and so on and so forth. And you can see the progression here, how quickly this goes, right? So you can see here how useful this is, right? No, buffer are not something that is very complicated in a GIS environment. It's one of the most, or the easiest function I would call, but it's very efficient, as you can tell. And you could argue, well, why don't you just run the script? Yes, you could of course run the script, but the advantage of having a tool is that you can share it. You can share it, and likewise you can share a script, but it's quite useful. You can, you know, embed this tool into a project and so on and so forth, and it's quite good. Now it does take time, as I told you, but we're almost done. So we're going to just wait that this process is done. Should take just 1 or 2 more seconds, or maybe 1 or 2 more minutes. You can see for each shapefile, if you don't remember, we have different. A shapefile is not just the SHP, it also has SHX, DBF, and other type of data sets. So we go back here into Arc Pro. We can close this script, close this, and if we really wanted to, but I may not do it here, or I'm just going to show you where the data is. So I go back to the C tab. I want to refresh, remember, and buffer here. You can see all the one from 100 to 200.